Yeah, okay. So yeah, so sometimes whenever we use the simple tower and stadium roof, sometimes we will not see the we have defining parameters options. So we have to minimize our software. So we will minimize, we have now parameters options. So here it is the tower parameters, like what is the base dimension and what is the top dimension and all. Like if the height of the transmission tower is of 30-meter and base dimension is of 8, and here we have top dimension of 4-meter, okay, and division along the height is 6. When click on the OK, so under the structure wizard we will see a shape like this. And at the top, if it is a single node, then under the VBA macros model option parameters, we have to provide the top dimension to 0-meter. But when we create a dimension of 0-meter length, then that means there will be a member of 0-meter length. Okay, and practically it is not possible to create a 0-meter length member, but software will create a model, create a beam of 0-meter length. Okay, so let me recreate it, just 1 minute. That is height of a 30-meter here and base dimension to the 0-meter, like this. Now I have to transfer this model to the STAAD here. Now at the top there is a member of 0-meter length. It happens in software, but in practically that is not possible. So we have to check it. So for this we have beam tools and other options, and like here go to the utilities here. So under the utilities, this is the beam tool option. We have to check, we can check duplicate beams, zero length beam and all. So here I'm just going to check a zero length member here. So software will show, you can see it, beam number 45 has been created with zero length value. You can see it, start node is 25 and end node is also 25. And in a single beam, we know at least there should be two nodes, but here we have only single node 25 and 25. That means both nodes have the same value. It is not possible here, so we have to delete it. So if you don't delete it, in the last you will get an error or error warning. So after that you will be understood it, but I just explained it because completed it many times. Okay, okay, now next thing will be properties. So for the steel structures, we have to provide property through the section database. So I just click on section database. It will take few seconds to open it. Now it is open. Here we have section profile tables. Okay. So we will pick the Indian design code. So here under the Indian design code, we have S shape, I shape, M shape, and along the S shape, we have ISLB 75, ISLB 100. That is the Indian standard lightweight beam. MB means Indian weight beam. I will show you one thing. For that, let me reopen it. Here. Okay. So these are the Indian standard beam profile values. So this is the ISLB 75 Indian standard low weight beam. Okay. And for the ISLB 75, weight of this type of steel for 1 meter length will be 6.10 kg. And it is written here kg per meter. That means 1 meter length value. Section area will be 7.71 centimeters. So that is the standard values. We can't pick any other steel rather than these values. Okay, we have to pick, we have to obviously all the manufacturer create Then depth here, this 75 will show you the depth of the section, that is the 75 mm. Now what is the depth of the section? For that I have to, okay, I have to open a file here. Let me see the image, section image. Just 1 minute. Yeah, here it is. Right. So that is the section depth D. It will be according to the type of steel shape. Like ISLB 75 means depth will be 75. Width will be 50 mm for ISLB 75. That's width, flange width. It will be 50 mm. Okay. It is given here. Width of the flange, that is a 50 mm. Thickness of the flange TF, it is 5 mm. What is the thickness of the flange? Here it is. It will be 5 mm. Same, that is the web thickness. So it will be TW. TW will be thickness of web. So it is according to the IS code, it will be 3.70 mm. So all these things will be according to the IS code. So either just pick it from this and you can check it along with it. You can check it in the STAAD also. I will show you the in STAAD also. It is a medium beam size like ISMB 100. So for the ISMB 100, weight of the steel will be 11.50 kg per meter, and other all parameters are given here. You can check all these parameters through the view table option also. If I click on the view table, so you can see ISLB, STAAD name ISLB 75, then axial areas that it was 7.71. So I just मैंने सब चीज explain की I just explained everything. I just showed show all thing in the uh, that particular any Google page. Okay, so depth of the slab was sorry, depth of the uh, section was 75 here. Width of the flange is 50 mm. Thickness of the flange is 5 mm. Then thickness of the web is 3.7. You can see all this table according to this also. Same if have a steel shape of tube, then we have tube 25, 25, 2.6. It's mean tube can be of circular shape also or can be of elliptical shape also. If it is of elliptical shape, then there will be two type of axis. Minimum, uh, there will be two axes. Okay, shorter length and long length. Okay, and 2.6 is the thickness of tube material. जो भी आपका material का steel shape, that is the thickness of 2.6 mm. Like in the tube, we have option tube 154. Okay, so one axis will be of 100 mm length, another axis of will be of 50 mm, and the thickness of the pipe, that tube will be 4 mm. So all everything is written on the its STAAD name. यहाँ से आप इसको देख सकते हैं, everything will be written here. So according to, okay, so the problem is, that is which type of steel we have to provide at any specific value. That is the problem. So this STAAD have an option. We can add it manually also, or we can add any single value here. Like I'm just going to add ISLB 100 for all value, and I will assign it to the complete structure. That means assign to the view. But you know that here this beam will be of wide flange, or it will be of ISW W or ISHB, wide flange beam or any heavy load beam. Because if it is a low weight beam, that means it can't bear the total weight of the steel shape. But here I just provide the ISLB for the complete structure. But whenever I will analyze it for the complete design, then I will provide check code commands and all. Then software will suggest you different type of steel shapes to provide at different positions. Okay, so let's see it in the output directly. Just next thing will be your support. So for the stresses, we can add fixed. Sometimes we have fixed and sometimes of pinned support here. So here at the bottom, I will add a fixed support here. Then go to the loading and all. Here I will add a wind load also, because the height of the structure is more than 30 mm. So for the wind load case, I have to give definition first. Okay, so for the wind, go to the wind definition, add it, and here we have IS 875. Okay, so in the V8 type version or in the later version of the Connect edition, we don't have the IS87 part option. We have it in the latest version of the STAAD Connect only. Okay, I said in the latest version of the STAAD Connect also, because later version of the STAAD Connect also don't have this. So I will pick the IS875 code, then add it, close, then click on add. So either sometimes we have data of height versus intensity, or sometimes we have to generate it. So here, if you don't have this data, then we have to generate it according to the few parameters, like for which city you are going to create a structure and what is the structure type and all. We have to select it. Yeah, one more thing. We I have resolution problem from in my laptop. That's why I not able to see the OK option at the bottom. Either I have to change it, or I can directly put enter to click on OK. Okay, that is the system problem, not the software issue. So this is not a thing. Just let me create it. I'm just going to save our structure first. Then I have to close it. Then I have to change my resolution. Personalize. Sorry. 125. Okay. Now go to the loading definition, wind definition. Now, now I'm able to see the OK option here. So first thing, we have to select the structure type, like it is the type of lattice tower. So I will pick the lattice tower here. Maximum height was 30 meter, and height intervals I'm just going to divide six divisions. Obviously it will be a 5-meter division. Okay, then we have to pick the city for which you are going to create, because we have to provide the basic wind speed value. If you don't have city option or your city's option here, then we can use it through the custom menu, and then you have to provide the meter per second option. For this, again, I have to open window. Okay, PDF. That is the IS875 party. So, F. Let me find any city here. Yeah, so here it is appendix A, under which you will see the basic wind speed option here, or you can see it through the this diagram also here. So here you can see different color codes, and according to that, here it is written the basic wind speed, like 50, 55 meter per second, 50 meters per second, 47 meter per second, and you can check your city also here. So according to that, we have to provide the basic wind speed option here. So like I'm just going to use it for 47 meter per second. So I will just provide this according to that. Next thing will be we have to calculate the designed wind speed Vz. The formula to calculate the designed wind speed will be Vz is equal to Vb multiplied by K1, K2, K3 and K4. That is the formula of design wind speed. So now what is the K1, K2, K3 and K4? Vb is provided by us here. Okay. K1 will be the risk coefficient, K2 will be your terrain roughness height factor, and K3 will be topographic factor, and K4 will be your cyclonic region. All these data we have to pick from the IS code, IS 875 code. Okay. So either just pick that data from here, or we can define it directly by the software. Like if our building is a low hazard building or a general building, temporary building, so according to that, these factors will change. Okay. So we can pick according to that. Terrain categories, there will be four terrain categories: terrain category 1, 2, 3 and 4. So what is the terrain category? Let me show you here. So these are the terrain categories. First one is the terrain category 1, that is the open area. That means here in this, here there are very few obstacles. Okay. And terrain category, in the terrain category 2, there will be few obstacles like this, and the height will be up to the 10 meter here, of the obstacle height will be up to the 10 meters. Same here, we have the obstacles in the group like this, and that is the terrain category 4, very dense area. So mostly a transmission tower is placed in a residential areas just for the mobile network. And if it is a electrical transmission tower, high tension line wires, okay, so that will be provided in the open area like a terrain category 1 or 2. Okay, so according to that, we have to pick our terrain categories, and according to these terrain categories, this K2, K2 and K3 factor will be changed. So I'm just going to put it for the K4. So when I put it for the K4, you can see the K2 value will be 0.8 like this. Up to the 30 meter, it will be 0.970. Okay. Okay. And when you provide all these values, after that we have to click on OK. So you will get the height versus intensity data. Sometimes you will get this data directly, like in a project I have it. Let me show you a project here. Just wait. So like in this project, let me show you the input data. So data will be given like this: zone factor value, importance factor, it was given, RF factor was 5, soil type and all, and wind efficiency, you can see it, we have intensity versus height data. So no need to do the everything which I just created, just you can directly add intensity versus height value from here also. And let me show you how to calculate the wall load. All here it is, I just provide the wall. Okay, how to calculate the wall load? Here it is, we have the density of brick here. Like in our previous project, I put the value 20 kilonewton per meter cube. Okay, I just assume it the 20 kilonewton. So all these things, sometimes it will be given, or sometimes you can, if you don't have this data, just provide the maximum data value, because if your structure is safe for the maximum data, then it will be safe for any other data also. Okay. So data will be given like this. So here I don't have the height versus intensity diagram, that's why I created through the generate option. Then click on add. Then there will be exposure factor. So add the exposure to the one to the everyone. Okay. Then exposure will be assigned to the complete view. So this is the procedure of adding wind definition. Next, we have to add dead load and all. Like I'm just going to add structure self weight command only. Then I will add wind load also. Let me save it. Sometimes whenever I add the wind load, software sometimes crashed. That's why I just saved it. Now next thing, wind load direction X. No need to define that range, because if you don't assign the range, software will pick the complete structure directly. Let me show you like this. If I define these values, so wind direction was from the x-axis. If I change it from the minus x, so it will be on the other face. And if I change the factor to the minus one, then the direction of wind will change. Okay. Same, if I change the range along the y, I just add up to the 15-meter height. So it will be add up to the 15 meter. Like sometimes it happens like here it is there will be a building structure of 15-meter height, and after the 15 meter your exposed value is from 15 to 30 meters. That means only up to this point your wind will be applied. So you can change this also. And if it is on a open space area, then no need to add any value here. It will be assigned on the complete. Okay. Now you can create the combination and all also. Add then post processing command, and add a story drift. Allowable story drift for the wind is 0.002, and for the uh, earthquake load it is 0.004. You can see it everything in the Bentley community also. This data you can check it from the Bentley community. So Bentley community is basically it is a website where you can, if you have any problem in your software, then you can search your problem on Google. Then directly you will get the first link. Most of the time you will get the first link of Bentley community, so that you can, and from the Bentley community you can check out your problems. Like if I want to check, let me show you the this thing. Like I don't have the data name, so story drift values for wind in STAAD Pro. Like if I just search it, so here it is. The first link is communitybentley.com. When I open it, so they will explain all these values according to that. Yeah, we have to search the IS code also. So you will get the result. So mostly procedure is that you can search your problems or data on Google, then you will get. Here it is. Wind loading is 0.002 times. Okay. So according to that, you can find out your problems for any type of error. For if you get any type of error in your output, you can search it on the Bentley communities. Okay. Now next thing is I have to analyze it. So just run it. Okay. Hmm. Now next thing is we have to do the steel design. So go to the steel. So first I'm just going to change the unit mm and Newton. Apply it. Then go to the design, steel design, and pick the IS code IS 800 and we have to provide few parameters here. So we have to check the deflection. We have to provide can parameters. If there is any cantilever type of member, then we have to put the can value to the 1, and we have to provide d maximum and d minimum. That means depth, maximum allowable depth. Like if I put the ISLB, if I put the d maximum to the 1000, that means up to the 1000 depth members can be checked here. And if I provide the d minimum to 150 mm, that means ISLB 100 will be ignored by our software. Only the member which have the section depth value more than 150 or 150 or more than 50 will be checked. So if you don't provide any value, then it will, if you don't provide any parameters here, then it will pick the default values, like d minimum will be 0, d maximum is the 1000. So like I am just going to provide the d minimum to 100 mm. So only the member which have 100 mm, more than 100 or equal to 100 mm thickness will be assigned. That means ISLB 75 will be ignored here. Okay. D maximum, FYLD yield strength value. Okay. Here it is FYLD. It will can be of 250 and all, जो भी आपका उसके according रहेगा. So you have to provide it. Then track parameters will print the minimum and maximum detail level. Like if you put the track 0, that means it will print the design with minimum detail level. And if I put the track 2, then it will print the maximum detail level. Like if your structure is getting failed, then due to the compression or tension by which it is getting failed, you will not get, if you put the track 0, you will get it in detail only when you provide the track to the track value to the 2. So I will add the track value to the 2. Okay. Then assign it to the view. Then after, go to the commands. So here, check code command, it will check different type of members so that you will get the exact member values. Then member takeoff and steel takeoff. Yeah, there and takeoff. There are two types of takeoff. So this takeoff means uh, the last one takeoff will provide the total weight of the structure. But if you pick the member takeoff, means in the steel there will be different types of member, and you will get each member's value using the steel member takeoff value. Then use the select optimize. If I select optimize means software will pick the optimum values. Like if I don't pick the select optimize value, so maybe your structure will you will create a structure with over values, like maximum values आपका, we can say the weight of the structure, weight of the steel will increase, require भी नहीं होगा, उससे ज्यादा का weight का आपका applied हो जाएगा. That means कि it will be over cost. Okay. So optimum size means software will pick the optimum values that will be required for your structure. So just add it also. Now assign all these value to the view. Now run the analysis. Okay. So come to the steel design here. So I just applied the ISLV 100. So for the member number 1, software is assigning its, sorry, I just assigned this value to the ISLV 100. Now I have to check is it fail or pass. So you can see the result is fail, because you know that where is the member number 1. So go to the geometry, click on the beam number one. So here it is a member number one. That is the low weight beam, and you know that I just explained that that beam will carry the maximum value, maximum load of the structure. So it can't be of low weight beam. So that's why it is getting fail due to the slenderness values and all. Next, for the member two, it is again fail. So most of the time you will see the output is getting fail. Here you will see the one more steel design that is by the software. This is why the ये हम लोगों ने किया था first one, that is ISLB 100, and that is the steel design next one. Okay, so here software is assigning ISHB 150 high weight beam. Okay, for the member number one, and it is pass. Okay, so you can get it for most of the members. What is the steel shape and type? Like for the member number 30, it is ISHB 150. और भी देखते हैं. Let me check. Okay, and if I pick the steel takeoff, second one, let me go to the properties here. Okay, so I didn't provide the ISHB 150 here, but software is providing the ISHB, ISSC, ISLB 125, and ISJB 150 also. Okay, and where it is provided, you can see it from the output also. Where is the ISJB and where is the SLB? You can see the for the each member. You can see it one by one also. Okay, so this is the procedure of applying, doing steel analysis and part. And after that, next thing will be foundation design and RCDC. So let me explain from the RCDC first. So just going to check it for the same structure which I created here. So for this type of structure, so the name of the file is a structure 3. I'm just going to rename it, save as with in the same file. Then I will reanalyze it also. Yeah, so now I want to do the concrete design on the RCDC. So for this, we have to go to the advanced concrete design option here. Okay, just click on it, then software will send your file to the RCDC. Okay, but in my system, in my software solution, I think I have errors. That's why I can't send this STAAD file directly to the STAAD to the RCDC. That's why I will just close it and I will open it through the RCDC directly. So you can do it directly also. But if you have any problem, then just open the RCDC and then import the STAAD file. And we can say I can export the STAAD file to the RCDC, or if I open the RCDC, then we can import the file. Okay. So here I'm just going to, first you have to provide the project name. Like I'm just going to provide the XYZ. You have to provide your project name, your client name, your engineer's name, and all, so that in the output, you जो अभी आपकी in the report file, there everything will be mentioned. Okay, is code value, then import the file. So just click on this three dot. So in the STAAD file, let me pen. stat files. Then file name was RCDC example. RCDC. Let me open PQR. Here it is. Now, what is the next procedure will be, if you are if we are going to do the beam design, so we have to pick the beam design. If I'm going to create the column design, so just go to the column and wall. So here I'm just going to do the column design. So I will pick the column and wall. Okay. For the beam design and for the slab, procedure will be same. If I want to do the slab design, we have to pick the slab here. Still, I didn't create any slab in the STAAD Pro. Still, software will get it according to the floor position, like total height. Floor will be at the 3 meter height or 7 meter height. That is the height of the floor. According to that, for which floor you are going to create it, we have to create. But one thing, we can create the slab design for each floor one by one only. Okay. And for column design, so just pick the column and wall, then click on create project. RCDC is for the for doing the concrete detailing. From the RCDC, we can create our uh, BBS drawing, that is the bar bending schedule, and even we can print our reinforcement detailing AutoCAD files, that is the drawing files, because in the STAAD Pro we don't have the RC designer. So for the this purpose, we have to use the RCDC. That is the Indian software designed by the S Cube company. That is the Mumbai-based company. Okay. So here, okay, let me check. I think it is clear now. What is the RCDC and why we are using it? Because now in the latest version of the STAAD Connect, RC designer option has been removed by software. That's why for the complete detailing, for the BBS drawing and all, we have to do the we have to create it through the RCDC only. So here, what is the concrete type and what is the steel? Like I want to use the FE 500 or FE 600. According to that, we have to select it for each flow. That is for the main reinforcement bar, and this is for the stirrups. So again, it's same values. Have to change. If you want to, okay, then we have to provide few design parameters. So go to the design setting. If you want to do the if you want to perform the ductile design, so you can do it. Ductile design, mostly ductile design will perform if your structure is situated in zone 4 or zone 5. So mostly there we use it, and if you don't want to do it, so just ignore it. Because for the structure ductile design, we have few more parameters, length to width ratio and all should be created. Yes. Then reinforcement setting. So minimum bar size for the column reinforcement bar is 12, maximum is 40. You like we can change it to the 40 or other also according to that. Shear wall reinforcement bar 8 to 40 tha, and link one is for the 8 bars. Round off values, minimum rebar spacing is 75. Sometimes contractor said like if maybe software will pick the minimum reinforcement stirrup spacing at 75 So sometimes it will increase your cost. So you can change it to the 100 also according to the requirement. But software will basically check it for 75 to 250. Minimum value is the 75 and maximum value is 250. Okay. If you want to change any values, so just change them. And here is the percentage column That is a ratio value. Just I just provided in the STAAD Pro. I just provided the ratio to the 4%. So you can see the minimum value 0.4 to 0.4%, and for the shear wall it is for 0.25 to 4%. Okay. If you have to change it, then either change or just click on OK. Next, after this, next thing will be reinforcement detail and drawing settings. So what you want to print can be arranged by you using these values. Okay. And then load case details. So our first load was dead load, so just pick the dead. Second one was live load, so just add it. Then you can add both of them, and after that we have to add the load combinations also. So for that, either you can import them if you have any values, or you can directly add it. जैसे आप उसको ओके पे, when you click on the OK, it will open the load combination window. So here our structure was a regular structure, so I will pick it for the regular structure, then click on the OK. So load combination has been added. Next thing is auto design. So software will design it. So if we here you can see at the left side, each column has its color green. If there will be a red color, that means that particular column will is going to fail. And we have the reinforcement detailing also. What is the bar size? And this is the link size, P8 at a spacing of 175 mm center to center. That is the stirrups. Okay, you can see it for the column one. What is the column one? Go to the design in layout. So that is the column one, and column one is from 0 to 3 meter, then 3 to 7, then 7 to 11. So everything you can, from the output you can see it. C1 from 0 to 3, then 3 to 7 meter. So what is the reinforcement detailing will be shown here. Okay. So that is the common thing. Software like STAAD is also providing all these values. STAAD maybe will spell anything. Okay. RCDC means reinforcement concrete design. Okay. So these value are we are getting these value from the STAAD also. Now we have to check the difference. So for that we have to go. We have a BBS option. You can click on the generate BBS. If I click on for the or column, so we will see the for all columns. I'm just going to open it for the column number C1 only. So I will pick the C1. So BBS is now generating here. That is the BBS drawing. This CAD file will help out you to create your structure on site. That is the column C1. These are the bars, 4 bars, B1, B2, B3, B4, B1, B2, B1, B2. Okay. So B1, what is the B1 and B2? So for that B1 and B2, here, bar 1, that is a bar mark, bar 1 and bar 2. Okay. And reinforcement bar size, that is the bar shape. Okay. So this type of design. We have other options also. I think someone's mic is open. Please check. So, so next thing, if you want to print these drawings, so we can save it. We have to save the project first, then only after we print. I think Mr. Subhendu Vikram.
Participants, please mute your mic. Participant Shubhendru, your mic, yes. Okay. Yeah, Amichi, it's muted.
Okay. Yeah, so now I can save this file in the CAD format. Okay. I just save this file. on the desktop, and same file I can check it, or we can modify the reinforced detailing if it is required through the on the CAD file also. And this CAD file will help you out you to create your project on site. So all these things can be done through the RCDC. Same we can create the beam design, slab design, and all through the RCDC. Okay, I can show the beam design for the same structure. Just going to open it. I'm just going to create a slab design. Okay, so because in the STAAD option, we in the STAAD Pro, even in the RC designer, we don't have option of creating slab properly. Okay, we can get only the area of the slab reinforcement through the STAAD Pro. And if you want to create detailed uh, that is the BBS for the slab, then we have to use RCDC only. We don't have any option to see the detailing of the slab reinforcement in the STAAD Pro. So just going to create a new project, this time for the slab design with the same file. Okay, I'm just providing any. Okay, so same file was saved in the D drive, so I have to open it again. And this time I'm going to create slab at a height of 3 meter and at the first floor. And you know that in the STAAD I didn't create any slab. That's why we have to provide the slab thickness here. Okay, so first I have to provide the slab thickness. So here we have slab for S1, S2, S3, something it is written here. Like I want to create a staircase in between here, so I don't need the slab S1, so you can delete it directly here. Like if there is no S1, that means, or you want to create a open for the lift purpose, that means here we don't require any slab, so you can directly select particular slab and delete them. So in the output, software will not create the slab detailing for this particular space. Okay, so first, thickness. So thickness for this slab was I want to add 150 mm. So just copy it, control C, select all these values, no need to write for each, we can just copy paste it. Then dead load and live load. So dead load for a slab will be like if a unit weight of concrete grade is 25, so it will be 3.75. Okay, so just type 3.75 here, that is the imposed dead load. Imposed load or dead load, that is the same thing. So just copy it and paste it for the remaining slab. Live load is of 2.5, like so. Just control C, then just paste it. Okay, then again design parameters like minimum bar size and all. Then load I just already designed, so that means no need to add, we don't have any load case option here. Just go to the auto design. So software has designed it, and if you want to see the BBS, that is the bar bending schedule, you can generate it, and even you can print the slab. Yeah, not is processing its data, just wait. Okay, and you will get bar size and all will be shown in the design output. Design, here it is. 8 bar along the y direction. Basically, in this RCDC, we have x and y axis. Okay, this direction is changed here. L x direction and y direction. So along the y distribution of bar is at a spacing of 230 and along the lx, sorry, it is along the lx at top and bottom. Okay, so at the top it is 230 along the x-axis. Bar size is 8 bar. So this is the tabular report and this is the BBS drawing. Next thing which I showed you here, top BBS. So BBS will be generated for the top and bottom individually, and you will get its value here. Okay, so and when we can convert this file in the AutoCAD also, we can create the section files also and all through the RCDC. So after this, our next topic is foundation design through the advanced foundation design. Okay, so one more thing in the RCDC we have, let me, I'm not going to save it, just wait. Okay, so through the RCDC even we can create the footing also. Okay, so RCDC will help out to create the footing, but we have STAAD foundation option also for creating the footing types and all. So I will do it from the STAAD foundation, but detailing of the slab and all can be done through the RCDC more precisely. Okay, yeah. So view file, that's the which I just opened on the AutoCAD. That is the column design file. Okay, now come to the STAAD foundation. So I'm just going to open the RCD, sorry, STAAD first, because I will export the file from STAAD Pro to STAAD foundation. It will import all the data like low reaction value and all. Okay, so I want to do the concrete design, sorry, foundation design from for this file. So click on the foundation design here. Okay, so just I click on the foundation design and just include the load cases for which you want to do it. So I want to do it for the all load cases, so I will pick the include all and click on STAAD foundation advanced. Same procedure will be for the RCDC also, but in my system it didn't work. That's why I just opened the RCDC directly. And same procedure, if you don't want to transfer the file from the STAAD to STAAD foundation, then just close the STAAD Pro and open the STAAD foundation, and you have an option of import STAAD. That means we can import the STAAD file from the STAAD foundation also, or directly export your file from STAAD to STAAD foundation. Okay, so still it is in the process. Just wait. Okay, so here this is the column positions, and here for the each column we have to create footing. So our first thing will be which type of footing we are going to create. So for that we have few different concepts like according to the building height, according to the structure type and soil type, we have to choose our footing. And still if you are not sure, like if you want to create a isolated footing and or combined footing, if you're not sure which one we have to create, then just try it with this with the isolated. If footing is getting overlap, then we can change it. Okay, so importing the file from the STAAD will import the all load data. Just see it. load case 1, here it is, reaction value at the column support is minus 2.95, along the fx, along the fy it is minus 353. Same thing you can see in the post processing reaction, then add node 1. Let me, so here it is 2950. It is in the newton, मैंने unit change किया था, I just change the unit, so it will be 2.9 kilonewton fx. Okay, so let me show you 2.95. You can see, so each data has been imported. Now one more thing, if you don't import the file from the STAAD, then our step will be just create each footing one by one, then add all these value one by one. It will take 2 to 3 hours just to define these values. So importing file will reduce your time. Okay, so it will just imported all the data. Next you have to create our job setup. So go to the job setup, click on create a new job, job name. Like I'm just going to create a isolated job. So I will provide the isolated footing job. Yeah, isolated footing. You can provide any name according, you can provide the name according to your project name also. Okay. Job type, isolated, design code, IS, Indian, then IS 456, then include your loading and click on create job. So job has been successfully created. Next thing will be provide parameters like a reinforcement value, unit weight of concrete, minimum bar spacing. So for the isolated footing, I'm just going to change the minimum bar spacing to the 75 and maximum bar spacing will be 450. That means software will check the value in between 75 to 450. Okay. Same yield strength of the steel is, what is the yield strength? We have to provide all these value. Then cover and soil cover, for the here we don't have the pedestals, so no need to provide this value, either software will obviously ignore it. Bottom clear cover is 50 unit weight of soil. Okay, this data will be given from the soil analysis procedure. ये आपका जो भी soil analysis का process होगा, you will get this data from the soil analysis. Okay, right now I don't have any data, so I'm not going to change, or either I'm just going to change it like 160 kPa and all according to the unit kilopascal, and you will get this data according to the soil analysis. Then footing geometry and minimum length value, maximum length value, you can change it also. Like if it is getting overlap, then we have to decrease the maximum value. If decreasing the maximum value will result in failure, then it means we can't create here isolated footing. We have to change the procedure for that. Okay, then sliding overturning, that is the constant value. After that, just click on the design and yes, save the file. Software will do the isolated footing here. So let's see. It is processing your data. So we are getting number of warnings 2, number of errors 0. Okay, so warning will be with the color. Warning can be ignored, but errors can't. Sometimes we can't ignore the warning also. Like if it is for the reinforcement detailing, then we can't ignore it, because warning can be of IBC, UBC, and other thing also. So let's see the detail output first. So bottom reinforcement is at spacing of 90 per center to center with a dia of 10 bar. It don't have the top reinforcement. Top reinforcement will only provide when there is any uplift force. If there is no any uplift forces, then no need to create it. Still, if you want to do the if you want to see the top reinforcement detail also, so we have to change few parameters. So go to the home menu, then go to the global setting, and under the rigid foundation setting, always calculate top reinforcement data, then apply it and reanalyze your structure. So this time software will provide the top reinforcement also. Okay, so here detailed drawing for the slab. First thing will be check will be your GA drawing. So when I check the GA drawing, I am seeing that here slab is overlapping. That sorry, foundation is overlapping. Footing आपका part that is overlapping. So either just reduce your maximum data from the footing geometry. Like maximum length is 6,000, so you can change it to the maximum width also like 5,000 for each. So maybe it will not overlap, but some still yeah, we have to find out the slab length first, because let software finish it, then I will explain. Come to the GA drawing. So that is the slab, that is the footing number 32. Okay. So for the footing number 32, what is the dimension? Footing number 32. F13. Sorry, 17. It is 2.9. That means if I don't want to overlap it, but we have to provide the minimum value less than 2.9 meter. Okay, so go to the footing geometry. Let me change the value to 2700. Maybe it will result in low. Okay, so let me check it. And most probably we will get errors. Most probably we are number of errors 14. That means overlapping. Okay, we can't create footing for this system. So that means sometimes on the site most of the engineers can rectify these values, because we can modify these values on the site also, or we can change the footing type to the combined or to the mat foundation also. Okay, so in a short period I can define up to this point only. So if you have any doubt, then you can ask, because this is the I only can explain the procedure of doing these values. I can't define each and every method in a short period. And for the, so you can ask your questions now if you have any. Same type of footing we can do on the RCDC also. RCDC has an option of pile cap and isolated footing, and even we can shift the footing positions also in the RCDC. That is the advantage in comparison to the STAAD foundation, because I'm just going to explain it. Like if you're building for which you are going to create a footing, and you have another building at your side, at your left and right side also. Let me show the GA drawing. Okay, so that is the corner footing. So column position is here, and we don't have spacing at the left side, because here it will be a another person's property. We can't create footing on another person's property. So in the RCDC, we can shift the column to the corner, and then we can create our footing. Okay, so any doubt, any question, you can ask.
Yes, participants, any questions? Yes, Arya Institute.
Good afternoon, ma'am.
Yeah, good afternoon, Amneetji.
I saw all the PPT presentation on this topic, but my question is, can we use response spectrum analysis for using seismic designs?
Yeah,
Or
we can.
okay, there are so many software in market, but we still use SAP 2000 also. But why
Okay.
we use these softwares for accurate values or any other thing? Because all the matters are same in all the softwares.
Yeah, obviously, according to all softwares prefer to provide values according to the IS code, and I didn't use any other software. Another software like a SAP and all. I just use the ETAPS and STAAD, only two softwares for the analysis purpose. So the output for the both softwares, almost we get the same values. Only sometimes we get the number of bar size and all differ from the another software, but mostly enforcement area and responsive spectrum values, everything we will get the same values, almost
Okay.
same, not always exact value, but almost same values.
Okay, sir. Okay, because I asked because I'm using SAP 2000 software, so
Okay.
all the applications that you use in this software are
Yeah.
same. That's why
Yes.
I'm asking these questions.
One more thing, I didn't explain the RCDC procedure here because it will take almost 1 to 2 hours, and we have very less time. So that's why I didn't explain all the options. Yeah, still I just saw the first project, that was the static analysis
Yeah, yeah, yes,
procedure of
sure.
the earthquake load. Okay, so I just explained that particular procedure, and in that procedure, even I didn't compare the output using the manual method and your software method, and I have a sheet for that.
Yeah, yeah, sure, sir.
Let me show you. Hmm, here it is. That is the same project which I
Okay,
showed you, and in this project, the manual procedure is also shown. Okay, now let me open the stat tool. Just I want to. So the same values. That's why I'm doing it. File open. Yeah. So come to the output. Yeah, here
Yes, sir.
we have VB value 1404. That is the base year value 0.09 and 15,600 s. Okay, so VB is equal to VB formula होता है, that is the VB multiply by AH multiply by seismic weight of the structure, that is the 15,600. It is calculated by the software itself. Now we can verify this data. Here it is, total seismic weight of the structure. ये manual calculation, it is the manual calculation, and you can verify it. And T value and all जो calculate किया गया था, everything. Let me show this thing. Just wait. AH is 0.09. Okay, and in the STAAD software here, VB is equal to formula. The formula that is the VB is equal to AH multiplied by seismic weight. So AH is 0.09. It is calculated by the software, and I just showed the manual calculation also. So through the manual calculation, we are getting the same data. Yeah, there is a one problem in this output. इन्होंने एक कैलकुलेशन मिस्टेक किया हुआ है मैनुअल. दैट इज द प्रोसेस. मैंने आपको बताया, हियर इट इज. VB is equal to AH multiplied by W, the formula which I described. That is for the base year value. And you can see AH is 0.09 and W is 15,609. When you multiply it, you will get 1404, not 1440. That's the thing we जो हम लोगों से गलती हो सकती है. This is the file the person who created, that is by Sudhir K. Jain, Department of Civil Engineering, IIT Kanpur. Even a professor of IIT Kanpur can do the manual mistakes. You can see it. When you multiply it, you will get 1404. That's why we prefer the software. When you multiply it, you will get 1404, not 1440. Okay, and from the software you will see the value 1404, 0.09 multiplied with 9. Okay, and now at the height of 4.2 meter we are getting total axial force 77.20, 77.205. Okay, अब ये कैसे कैलकुलेट करते हैं? जस्ट सी द मैनुअल. हाउ टू कैलकुलेट दिस वैल्यूज? वी हैव lateral load formulas. WI square multiply by divide by sigma WI square. ओके, सो ये फॉर्मूला है लेटरल लोड का. यहाँ पे भी ऊपर लिखा हो तो मैं आपको दिखा दूं. लेट मी शो द फॉर्मूला. आई थिंक इस सीट में नहीं हो, दूसरी सीट में है. सो इन्होंने जो कैलकुलेट किया, लेट मी go to the output. So at a height of story level 1, lateral load was 79. Okay, because abhi we have the output 77 point something, but they have 79 because VB वैल्यू चेंज हो गई इनकी 1404. दैट्स व्हाई इनका डेटा थोड़ा सा इंक्रीज मिल रहा है. ओके, सो दैट्स नॉट प्रॉब्लम. यू कैन सी द आउटपुट, मैनुअल आउटपुट एंड सॉफ्टवेयर आउटपुट, इट इज ऑलमोस्ट सेम. ओके, तो आई थिंक आपका डाउट ही यही था कि सॉफ्टवेयर से क्या हमें एक्यूरेट डेटा मिलता है या नहीं.
जी सर. ओके, my problem has been solved out now.
Anything else from anyone?
Yes, sir, I have one doubt.
Yeah, sir.
Yeah. So my question is about the RCDC design output.
Okay,
So, sir, can you open that output?
let me open. Yes.
Sir, I think this is not the one. The whatever the you have shown the that one.
I just showed the concrete column design and slab design. I think you are asking for the slab design.
No, no, column design only.
So that's the same file. जो मैंने भी create की है. You can see the file name, column design. Yeah, let me check. Let me check. Let me check.
It is the another one.
Yeah, yeah, I'm just checking it. That was RCDC example, I think. I
This
think
one.
this one.
Yeah.
Yeah,
So if you see in the C4 column 4,
yeah, C4. Okay.
yeah, yeah, this one. So I think we can see the in the bottom it is 416, right?
Yeah,
And at the top it is shows 416 plus 412. How
yeah, correct.
so normally we can as we know that when we are going from bottom to top the reinforcement is reduced.
Yeah, obviously.
Yeah, so right now at the bottom it shows four numbers bars only, but in the top it is shows eight numbers bars. Though the diameter is varies, but it
Hmm.
is how we can provide eight numbers of the bar.
Yeah, I just explained one more thing. Just when I was this software will provide you the reinforcement area also, and I just told one thing that if you are not satisfied with the software's output, that means number of bars, because most of the structural softwares like SAP or any other thing don't provide the number of bar size. Only RCDC and STAAD provides the bar size, but these software provide the reinforcement area. So in that condition, you don't want to increase the bar size, then we can provide the bar size by doing the manual calculation using the reinforcement area option also.
Yeah, that is okay, sir. But so basically, whatever the design shows by the RCTC, we are not able to directly give to the site on the
Even
site.
sometimes, yeah, even sometimes in the STAAD also, you can see, I'm just going to show the same
Yeah,
file.
this,
I can show the same file in the STAAD also. Even
yeah.
sometimes STAAD also increase the bar size on the top position. Okay.
Yeah, yes. Even though I know that in the stat, the though the in beam also the on the corner the reinforcement is different. Even though the diameter is different in the center, the diameter is different, and again at the corner again the diameter is different. So normally we are not supposed to provide that type of the design on the side.
Yeah, obviously.
Yeah. So here also the same funda we have to apply. So we have to just see the reinforcement area requirement only. So based on that, according to our knowledge and experience, we have to give the design to the site.
Yes, yes, sir. Obviously.
Yeah. Okay. Fine. So I think I might be I am not knowing about this, so that's why I'm asking. Otherwise, if the designs given by the RCDC in proper way, so we can directly give the output file to the site, so we can save the time. So that's why I'm asking you.
Yeah, yeah, yeah.
Okay. Fine. Thank you.